Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students of Senior 3 Chemistry class. I'm very excited once again to be with you in this lesson number 8, and I'm sure this is the last one. We have gone along together, and I just want to thank you for being there. In lesson number 8, to be very specific, because we said we have looked at very different concepts. So this time we are just going to look at electrolysis of different solutions. It is just demonstrations. So we'll be demonstrating these electrolysis of these solutions that I'm just going to show you. And we also do what we have just finished, or what we finished in the previous lesson about the electroplating. I hope you still remember what the electroplating means. And if I can remind you, we mentioned about the coating of the metal with another metal, the surface of the metal with another metal using electrolysis. That is what we mentioned about electroplating. So we just move to the demonstration of different solutions. So here I have table salt. Actually, it is sodium chloride. So that is the one we are going to look at first. So we'll be looking at the electrolysis of sodium chloride solution. So that is what we are going to demonstrate first, electrolysis of sodium chloride solution using inert electrodes. So here we have sodium chloride, which is solid, and I have some distilled water. So I'll have to dissolve it in water. I have to add enough water to make sure it dissolves. And once it dissolves, sodium chloride is very soluble. So all the electrolytes must be soluble. So I have to make sure it dissolves. So I'm making a solution of sodium chloride. And I'm just going to pass electric current. And then in this solution, we are passing electric current that will decompose the ions which are in the solution, and then the movement. The electrical energy, this is the device. It is used to convert. It is connected to the alternating current. So it converts an alternating current. This device here converts alternating current into direct current. So we always use direct current, not alternating current. So basically now it is off. So when I put it on like this, you see it lights. You see it lighting. That is the means it is on. So this is a solution of sodium chloride, as we have said. This is the switch. These are electrodes. We have this one. This is one of the electrodes. I've just got these ones from the dry cells. You don't need to buy the electrodes. Once you have the used up cells, dry cells, then you can get them from there. These are the electrodes which I just got from the dry cells. And they can be used. These electrodes are made of carbon. Made of carbon because they can also conduct electric current, which is graphite. So I'm just going to insert these electrodes into the solution, and then you will be observing what happens in the solution. So I've not switched on. I'm trying to put these electrodes inside the solution. So you have to make sure these electrodes are not touching each other. You have to separate them. So once I switch on, so I first switch on this one to make sure the electric current is, passing. The switch is already on. What is happening? Just look at inside. When you look inside there, I just want you to see what is happening. There are bubbles of the gas. And these bubbles of the gas, I think all of them are colorless. They are colorless gas. So you see the bubbling taking place. I hope you are seeing it properly. And that means the gases are being produced. Gases And which are these gases? This is a dilute solution of sodium chloride. A dilute solution of sodium chloride. So I can switch off. So once I switch off, we are just going to see what is happening. So we have sodium chloride solution, the sodium chloride solution producing, of course, in the solution as an electrolyte, it will be producing the ions. These are the ions present. And then you have water as well. So you have the water as well. So this water also produces the hydrogen ions and the OH ions in the solution. So what is happening? So we'll see that there is a gas produced. So these ones are moving to the cathode. As we had discussed previously, I'm just trying to remind you this is moving to the anode. But when they reach at the anode, the respective electrodes, one of them discharges. One of the ions discharges. You remember we mentioned the factors: electrochemical series, the position of the ion in the electrochemical series, the concentration of the ion. We mentioned the nature of the electrode as well. So here we are looking dilute solution. So the hydrogen ions discharges. So we'll have the hydrogen ions discharges, or these hydrogen ions can be, so that is at the cathode. So we have at the cathode, you have the two hydrogen ions gaining electrons to form what? To form the hydrogen gas. Or we can also write this in a different way. So the water molecules gain 2 electrons to liberate the hydrogen gas, plus the 2 OH ions. So there are 2 ways of how you can write these equations. The hydrogen gas is being liberated. What about this was a cathode reaction. What about at the anode? So you need to remember, we saw the bubbles of the gas. If I can just remind or take back you where you see bubbles of the gas immediately coming back. You see the bubbles of the gas there on the electrodes. Where are these gases, and which are these gases being formed on the electrodes? That is what we need to know. So that is what I'm trying to explain. So you have at the anode we had the OH and the chloride ions. So the OH ions, as we had discussed earlier, are the ones losing electrons to form the water molecules, plus the oxygen gas, and then plus these are 4 electrons. What is important, we are just looking at this, the oxygen gas that is being produced. Or we can write this in this form: the water molecules oxidizing to form the oxygen gas plus the 4 hydrogen ions with the 4 electrons. We had talked about these reactions even before. So that is a solution of sodium chloride. We can have other solutions. This is potassium iodide. So we are also going to electrolyze potassium iodide solution, and then we see what happens. Do we get the same solution? Do we get the same ions? So I'll just put them here, just to get some few crystals of this potassium iodide. This is potassium iodide solution. I just want to make a dilute solution. So I will add water in this solution to make it dilute. Electrolytes must be in water. So this is a solution which is dilute. This is a dilute solution. I just want to remove this. I don't need this anymore. So let us now this is potassium iodide. What do we expect? Potassium iodide solution. It is going to be electrolyzed. So let us check what happens. I'm just going to switch on. When you switch on, I just want you to take note of what is happening. Do you see the gas that is forming? You have on one electron, you see so many bubbles, and on another one, you see another different color of the gas which is coming. So which gas could that one be? You see the other one, so many bubbles, and then you see the other one is a bit brown gas, yellowish brown gas being forming on this electrode. And which electrode is that? And then we have the other one which is bubbling very fast, which is colorless in the solution. So the solution, look at the solution, it is changing. What is that one? So this is what we're just going to explain, what happens in the solution. So the potassium iodide produces the potassium ions and the iodide ions in the solution. Remember we said there is water because it is a dilute solution, so you have hydrogen and the OH ions. We are using the same. So the hydrogen ions here discharge. So we have a colorless gas. The colorless gas was forming on this electrode. So this electrode must be the cathode. This must be the cathode. This is a negative electrode. This is a positive electrode where the anode, where the iodine is produced. So at the cathode, we have the hydrogen ions gaining, that is the reduction to form the hydrogen gas. Then at the anode, we have what was producing there. We see this brown yellowish gas. So that is iodine being discharged. So the iodine being discharged in preference to this. So this solution is likely to be concentrated. So the iodine, how does the iodide ions are now changing. They have to be 2 iodine plus the 2 electrons. This is the iodine, which is brown, which is a brown in color. So it is the one that is changing this solution, yellowish brown. So that is what is happening. So we are just going to look at another experiment. This time we are using copper, and we'll have to do we have to use these 2. This is zinc electrode, this is zinc, this is copper. This is zinc, this is copper. So we are going to do what we call the electroplating. So how do we do the electroplating? You remember the concepts that we talked about? During the electroplating, the metal to be coated must be connected to the cathode. So we want to coat this one. This is zinc, it is covered, so it is zinc plate or zinc electrode. And we are just going to cover this one with copper. So we are going to electroplate it with copper. A thin layer, we expect to see a thin layer of copper to cover this one, so we will not have this white or this shiny white substance. And this one will have, instead of we are just going to use, this is the metal that will be used for coating. Or let us first use the electrodes only alone. Let's use inert electrodes because this one helps us to understand the coating process, how the coating process takes place. So we are just going to use the same electrodes which are inert, these same electrodes, and we are just going to dissolve copper 2 sulfate solution. This is copper 2 sulfate, and we are going to make a solution of it. So once we make a solution, I don't need all this. I can just separate it like this. make it more dilute. Make it more dilute, like that. We are using the same electrodes. So what we are electrolyzing now, it is electrolysis of copper 2 sulfate, but we are using inert electrodes. So there are 2 electrodes, all of them, the same inert electrodes. Carbon is inert, less reactive, to be precise. So that is what we are just, let's electroporate, let's carry out this process of electrolysis of copper 2 sulfate using inert electrodes. I think it is on. Yes. So what we need is, we are just going to see what is happening. So on one of the electrodes, you see the bubbles. So when you look at both electrodes, you see the bubbles are being produced. But on the other one, we are not seeing anything. Does it mean that there is nothing taking place? We are just going to see. One of them, there is bubbles being produced, and another one seems like as if there is nothing going on those 2 electrodes inside. I hope you are seeing what is happening inside. I'm just going to remove them from the solution and see. Also on this, we see some bubbles coming up. Let me just put it back. But what is on this? So we can even leave them there for some time. So when you look into the solution, this solution was pure, but we see some other things are coming in. Some spots which look like black. You see, the solution is no longer pure. There are some things which are coming in there. So what could those ones be? So what is happening here in the solution over there, you see the gas over there, but when you look at this one on the side here, it appears as if there is nothing. So what is happening? At the anode, now we need to first look at the ions present. You have copper 2 sulfate, so the ions present, you have the copper 2 ions and the sulfate ions. You have the water present, so you have the hydrogen ions and you have the OH ions. So this time copper discharges, we are looking at the cathode reaction. Here we'll have the copper being discharged. So that means this one is changing into, there is some copper, is there any copper that is coming? Where is the copper coming from? There are some ions in the solution. So here we have the copper ions gaining electrons because it is a reduction and then changing into the copper. So we expect, you see some spots. After some time, if we leave it there for some time, it is somehow turning, changing to this color, but very little is coming. So it is just a matter of time. Just leave it there. Just look at what is happening there. This is not carbon, because carbon is less reactive. You see some particles, these are solid particles, which are depositing down. And which are these particles? They are particles of the copper that is being formed. And that is what is happening here. At the anode, you will have the oxygen discharging, so you have a colorless gas. That is where you will have oxygen, then water, plus the 4 electrons. So those are the reactions that are going on. Now we can see, what if we change this one now into these different electrodes? We are just going to connect the different electrodes. We are changing. these electrodes. So this one we are making, this is the copper electrode. Let's make another solution. Probably that one will not be enough. Right, this is enough solution of copper 2 sulfate. We can as well dissolve it more. So, but what is important is that it has, the solution is dissolving. Copper 2 sulfate is very soluble, so it makes an electrolyte. So we are going to insert this electrode. We said this is anode. And then we are going also to use, this is a zinc electrode. We put it over there. We can make sure it doesn't so you can see what is happening. Is this one still white? No. What about this? Do you see anything happening? You may think there is nothing that is happening. So we are using the same electrodes here. The electrodes are the same. These are same, they are all made up of the metal. So this is, what is happening to this one? There is something that is coming on this electrode. Something is coming here. And what could that one be? If you can predict, what could it be? So we said if the electrodes are similar, so it is still the same solution, electrolysis of copper 2 sulfate, but here we are looking at the same electrodes. So what do we expect? Even when you look inside there, you will tell that there is a certain layer. This zinc is covered by a certain layer. And that layer is coming from where? This is pure copper. So we expect the pure copper to be dissolving and then form the ions, increase the ions in the solution, and those ions are supposed to be depositing on the zinc plate. So that is what is happening. We said this is electroplating, a metal coating another metal. So this metal is coated by another layer. And this other layer is coming from where? You remember we said that the metal used for coating has to be pure, which is anode. It has to be pure. That is very, very important. It has to be pure. So here we have the anode reaction. At the anode, we expect the copper, which is the metal. After some time, maybe we would expect it, if we had time, we would weigh from the beginning and then weigh again. So this copper, so we expect the anode to reduce in size. And then you have the cathode. What is happening at the cathode? This copper that forms in the solution now is deposited over there, and then it forms the copper. So you have the copper coating the zinc. It is coating the zinc there. So that is the reaction that is occurring in that reaction. So those are some of the now, what if I can change this one? zinc. If I put there this electrode, what will happen? Let us see what will happen. It was pure copper. We expect some other layer to come and quad. When you look at this, after some time, this one, there is no change. What about this? It is very fast. So we need to wait and see what will happen later. There, of course, there must be something that will have to happen. One of the plates will be covered by another layer of the copper, though it is also made of copper, but it is covered with another layer of the copper. So that is what will happen. So those are different demonstrations that we are supposed to look at. We are supposed to look at the electrolysis of copper 2 sulfate using the graphite. So we used the graphite electrodes, and the procedure that one indicates the procedure that we are supposed to do. We have carried out actually that procedure. As I was showing you, the procedure is all indicated. Then some questions. Write equations that occur at each electrodes and explain. I have writing equations and I've been explaining what happened to the solution of copper 2 sulfate at the end of the reaction. So here, we are expecting the reaction, because the copper 2 ions here, when we are using inert electrodes, when the reaction continues, we would expect the reaction it keeps on fading. And as it fades, at the end of the reaction, the reaction becomes colorless. Why? Because the copper 2 ions are being removed from the solution, and therefore, what happens? The solution will change into colorless. But when the electrodes are the same, because we said that if the electrodes are the same, what happens? We expect the solution to remain. Why? Because the solution, the copper 2 ions are removed from one electrode and replaced at another electrode. Suggests the nature of the solution of the electrolyte that as proceeds, I've talked about that one. So those are some of the demonstrations that we wanted to show, and I hope you have been following. I thank you so much for being there. Please have a good day. Stay safe, and let's meet in the next lesson. Bye-bye.